要过来哦，快点东西。
Đó, tự yếu á. À, ok. Okay, so good afternoon. Welcome to this training overview of vertical transportation system. So in this training, I will share with you all on the vertical transportation, which are lift and also escalator. So we will be going through the design, regulatory requirement, and so on. So this training will take around 4 hours. Around 4 hours. I will share with you all on the session plan as well as the course outline later. So this is the course outline. So the title is a vertical overview of vertical transportation. Duration 4 hours, and we have our training here in Perunding CHLT. So the learning outcome. So at the end of this session, participant will be able to understand and describe elevator system, safety components, and engineering calculation. And you will also be able to understand and describe fundamental of elevator traffic analysis, and also understand and describe escalator system design and safety concern. So the learning outcome and the point is stipulated in here. So I will start with the trainer profile, then we will proceed with the icebreaker, then I will share the learning outcome, which is what I'm doing now, and also the content mapping. So after that, we will go through module 1, vertical transportation system, where I will introduce vertical transport system. I explain the history and development of the vertical transportation system, and I will also explain the use of the vertical transportation in Malaysia and its regulation. After that, we will recap and also have the group discussion and also the small quiz. For the module 2, we will continue with the fundamental of a lift system. We would like to give opportunity to understand the traffic requirement of lift system, design and construction of the lift system, and finally I will talk about traction machine as well as roping system. So I will also do a recap and also group discussion and also the small quiz. So I will go to internet, to Google, to download some of the article, then we can go through together for the group discussion. So for the module 3, I will share about traction evaluation, how the traction force be applied to move the lift up and down. Then I will also talk about lift car design, and as well as ropes and cable. So again, I will explain analysis and calculation of traffic elevation, explain lift car sizing and design, rope construction, safety factor calculation, and also cable. So after that, we will also have the recap, group discussion, and also quiz. Module 4, I will talk about escalator overview and safety. So for escalator, it is actually relatively simple. So I will only talk about concern of the vertical transportation again, and I will talk about escalator overview, escalator safety, as well as the safety concern. And then at the end of the training, I will talk about a summary, and then we will do the recap together and also review the outcome. So in general, the lecture we will wrap up for all the modules, and all throughout the training, the activity will be the simple quiz, and we would like participants to be engaged. So far, any question? No?
No, thank you.
No, thank you. Okay, trainer profile. So this is my profile. I am a professional engineer with a practicing certificate, registered with a Board of Engineers Malaysia. I'm also a member of the Institution of Engineers Malaysia. Recently, I have been upgraded to fellow. So I have more than 22 years of the experience in quality assurance, R&D, product development, and project management in vertical transportation, electronic, as well as automotive products. So this is my email, and you all can reach out me by calling me or WhatsApp me. So let us move to the icebreaker. So please introduce yourself and we learn together. Maybe let me ask Chan to introduce himself.
Hi, thank you, Dr. Lee, for being here with us. I'm the owner of the company for Perunding CHLT. It's very honored to have Dr. Lee here to share on the insights of the design and safety on the lift vertical systems. I'm honored by the end of this session. I hope I can also learn the tips in order to make my design better. I pass it to the next participant.
Lance.
Hello, ladies and gentlemen. My name is Lai in the Information Technology Consulting. Excited to meet the trainer, Lee, and also fellow trainees. Also excited to learn about the insight of vertical elevator system from experienced doctorate fellow of IEM, Dr. Lee. Thank you.
Hi, I'm Engineer Ong. I come to learn new thing from Dr. Lee.
Thank you all.
Hi, good afternoon, ladies and gentlemen. I'm a professional technologist, Ng Xiang Boon. I'm happy to join the seminar of IEM Fellow, Dr. Lee Chu-Yo. I would like to learn the vertical transportation system from Dr. Lee. Thank you.
Okay, thank you for your introduction. So without further ado, we can move to next section. So learning outcome. So by the end of the session, as I mentioned just now, we will be able to understand and describe elevator system, the word system, safety component, and engineering calculation. So this is a technical training. Understand and describe fundamental of elevator traffic analysis, and understand and describe elevator escalator system design. Next, we will move to the content mapping. So module 1, we will go through overview. What is a vertical transportation system, or VTS? We will cover the overview, history, and also context of vertical transportation in Malaysia. Module 2, we will talk about design. We will talk about traffic requirement, design and construction, traction machine and looping system, which are essential or the core component of the vertical system. Then module 3, we will mainly discuss about design criteria, traction evaluation, how can we have the good traction force to be applied with car design as well as the loop and cable. And model 4, we will talk about overview of escalator and the safety concern. So I believe that this will be an important topic, so that not only for engineer but also for the public as well. Yeah. So far, I believe no concern. So let us move to module 1, vertical transportation. So as the name implies, vertical transportation system, they transport people and materials inside building vertically. Vertically, the keyword is vertically. So the lift that we see in the shopping mall, in the apartment, not only carry the people, but they also carry the material. For example, goods lift. Okay, they carry the lift. So most of the goods, we can see a very big goods lift in which area? Maybe we can have a guess. Shopping mall
and warehouse.
Warehouse. Actually, warehouse is the correct answer. And the biggest, one of the biggest goods lift that I have seen is actually at the KLIA. KLIA. They transport the goods to be loaded to the aircraft. And then one of the biggest lift, goods lift together with passenger service lift is actually the lift in IKEA Damansara, 74 people at one time.
Is that car lift is bigger than the goods lift? Because car go inside, the size of car and the weight of the car gonna be 2 or 5 ton. 2 ton.
1.5 ton.
1.5
Typically 1.5 ton. The design is 1.5 ton. Last time I designed a car lift for one of the shop lot in Falim. Last time Falim, they have the so-called they have a shop lot at commercial center. They have ordered 2 car lifts. But that one I think only 3 story, because they want to transport the car for the exhibition to to the hall room for the exhibition. So for the KLIA lift, what I know is it can actually withstand forklift because the forklift needs to enter the goods lift, then they have to unload the pallet. Okay.
So, forklift is heavier than the car.
Yes, yes. Especially when the wheel actually touch the car seal and landing seal, that will be the force applied to that. So the guide rail must be able to withstand the force because it's actually eccentric force.
Moving a forklift inside a.
Yeah, so that they can unload the pallet.
Oh.
Yeah.
So the pallet, I mean the lift inside, the forklift inside the lift must also carry the goods.
No, the forklift will carry the pallet, then they will unload into the lift, then the forklift will move out. Okay.
Double width.
So this is an eccentric load lah.
Very.
And the base must be very solid.
So for car lift, we cannot use only one pair of the guide rail. We need to use two pair of the guide rail. So that is the reason. So it is important system of the building services engineering. So in any building service engineering, so we talk about lighting, we talk about aircon, but usually vertical transportation is not really been emphasized, but actually it is also equally important. So this training will give overview of lift and escalator system design, safety component, traffic analysis, and also relevant guideline. Guideline means from the authority or also for the design. So vertical transportation, so I look at the holistic view. So you see, even inside the ship, inside the convention, inside the tower, inside the building, inside the subway, there will always be the vertical transportation element. So they are very important because it allows access of the people, of the goods into the facility. For example, without the lift, you will not be able to reach here. Or without the escalator, you will not be able to reach the subway. Of course, you can walk, but then you need to transport 1 or 2 or 3,000 people in 1 hour. I think you cannot have enough staircase, so you have to use an escalator and the lift system. Another advantage of the lift in comparison with escalator is, okay, maybe you have a guess. Why in some subway station they already have the so-called escalator, for example KL Kelana Jaya line, why they still need to have a lift? Have a guess? We already have the escalator up and down, why next to the so-called like for example KL Central, why we still need to have a lift?
To help the handicapped people and also whoever carry too much luggage, they can take the elevator.
Yeah, with the wheelchair.
Uh,
Yeah, I think lift is important, right? I think for
Yes,
the building
for,
design.
especially hospital, you need a leave for evacuation.
Evacuation.
Or non ambulatory patient.
So that's the reason why. So these are the main player of the vertical transportation. Fujitec from Japan, Mitsubishi Electric, Sigma is from Korea, Hitachi also from Japan, Toshiba, Schindler is from Switzerland, ThyssenKrupp from Germany, Otis and also Koni. Among this company, Otis is the oldest one. Otis is now a part of the United Technologies, so they are developing a high-speed elevator as well. And then for Koni is based in Finland. So in fact, one special thing about Koni is they don't have the test tower. They built the test tower in the tunnel, in the mining site. So Fujitec, last time they used to be the partner for the Housing Development Board. Last time all the HDB flat they use Fujitec. Okay, and then Mitsubishi, of course, they are famous for their reliability. And most in KLIA, mainly Mitsubishi. Otis, Otis actually have the remarkable elevator system in KLCC. KLCC lift, they use Otis. And then Schindler in Menara Telecom, double deck elevator. ThyssenKrupp is from Germany. I think for ThyssenKrupp, they also have a heavy duty goods lift, and for Koni, they are supplier of the vertical transportation system for Menara 118. Menara 118.
Toshiba elevator is in Blind.
Toshiba is in Blind. Koni is also famous of its innovation in developing the motorless lift. Okay, so now we can see the high-rise building. Okay, what is the high? You see the highest speed is actually can go to 20.5 meters per second. 20.5 meters per second. For this one is in Dubai, this one is in Shanghai, this one I think is for Saudi Arabia, this one in China, Otis and Mitsubishi. Okay, some of the tower they have the different lift supplier, and then ThyssenKrupp in US, Guangzhou Financial Center, Taipei 101 from Toshiba. This one I think is from Shanghai also. This one, I don't know how come the so-called the wording is not clear. But for for KLCC is actually Otis 7 meters per second. So in every second it can travel 7 meters. So this is these are the overview of the high-rise building. In fact, there is a organization so-called Council of the Tall Building. So they will actually compile all of the data and then they will renew the database. Alright. Okay, so in terms of elevator design, so what we see is faster and tallest. So what is the limit? So the worst faster elevator 20.5 meters per second. So in order to achieve a 20.5 meters per second, the design consideration is just simply beyond the traction machine, but it also need to consider the aerodynamic. You see, they have to do a lot of the aerodynamic simulation. Even though when they design the lift car, they also have a different shape. In fact, most of the simulation are very similar for aerospace engineering.
But in actual case, is it allowed, the JKKP allow up to 20 meters per second or not?
This one is
So
this one
far
is
I know
overseas,
it's normal is only very
high.
yeah, this is very high
Very high
compared
is
to ours. No.
7 meters per second.
Faster
Yes,
than
yes.
year 20.
Very fast. This one is very fast. This one, all these are so-called
Super fast.
super high-speed lift. And then the travel. So this is a travel. So in order to achieve such travel, they need to also consider the loop swing. The loop swing, because this is too high, the loop can swing. So they need to consider a lot of things. So recently, I think a few years back, Koni developed the so-called the ultra fast loop, which is made from the composite material, which is lighter and with the less friction, so that it can move faster. Yeah, I think we also talk about double deck lift. What is the reason of the double deck? You can double deck, that means in one lift they have a 2 cabin, one up and down.
Balance.
No,
Oh,
different floor.
Reaching different
Okay.
surface.
When one of them need maintenance, the other one can function.
No.
Like
Actually,
a-
it's in one car cage, one
For
lift.
serving different floor, like
Yes.
what you say.
So it can actually double up the capacity. But this kind of the double deck elevator is really uncommon. It's really uncommon. So I say that in order to meet this kind of high speed lift, they need to have a new technology for the traction machine. Yeah, they need to have a powerful permanent magnet motor with a very large capacity of the power supply for the inverter. And then they need to make the car frame or car design which have the aerodynamic features to reduce the air resistance. Similarly, as a so-called the guide rail, so they need to have the adaptive guide rail because the guide rail is simply too high, so there could be some tolerance. So the guide rail must be able to absorb the vibration.
Dr. Lee, can I ask a question related to the belt, rope or chain? Why there's a different type of the method to move the car using different things? Is that any reason rope is preferred?
Yeah, rope is definitely a solution because rope have the tensile strength, and then rope have the is actually because the movement of the lift is actually caused by the traction between the groove of the shift and the ropes. Therefore we need to use the rope, which can initiate or generate or maintain sufficient traction. So for the chain, actually it can be used for the good hoist, very low speed. But I think in Malaysia, they don't really recommend for some of them. Even some of the good hoists also use the rope. For example, Coney crane, they just have the hook and then they hook up the hoist. Chain, I think usually only for chain block.
Is that belt is only allowed only non
What do you do?
like carburetor or what, or belt is totally not allowed?
Belt is allowed. In fact, Otis Gen 2 lift, motorless lift is actually using the belt.
How many number of belt?
Okay, they need to look at the so-called catalog, because it is related to the road. Otis is the one who invented the belt. But what I remember is long time ago, Otis need to apply for the exemption from JKKP to use the belt for the Gen 2.
So Gen 2 couple with how many belt again? Sorry.
Need to look at the catalog.
So you have multi-belt also?
Multi-belt also. But they need to get the exemption from JKKP.
I think some homely is using belt.
Some of them can use belt, right?
They are using
I
belt.
heard that also.
I don't know how many number of belt.
It depend on the load, So as you can see, there are also a lot of challenges when designing the high-speed lift. But of course, this kind of system is actually superior and not easy to do. They need to have a very strong R&D, and they also need to do a thorough testing.
Dr. Lee, I entered the hotel elevator control room before. I see the belt. So for this skyscraper one, the high building one, how is the control room look like, the elevator control room?
Also in the top.
I went to the hotel, the highest floor. There's one control room that control all the elevator one. I entered that before.
You entered before You call motor room You see the motor? You see the motor?
Because that time, at one time, I was the maintenance manager of one hotel. So I went there before.
We will go to that as well.
Okay.
In the design and construction. So now we can take a look on the history of vertical transportation. So at a glance, I would like to talk about safety gear, which is important. The most important element for the lift design, electric lift, and also the motorless lift. So these are the three main things I will talk about in history, because it really make a lot of difference. From safety gear, then we can move on to electric lift, and then after that, in order to save the space, we can have the motorless lift. So the safety gear, demonstration of safety gear by Elisa Grave Otis at the Crystal Palace. So the very first design of the safety gear is he designed the two rail with the gear teeth, and whenever if let's say the rope is broken, so actually the gear will engage with the cabin, so it will stop. So this is the actually the most important person in the elevator history. So you see the name Otis. So he is the founder of the Otis elevator. So Without this safety gear, I think the evolution of the lift will not happen. Because there's before invention of the safety gear, there is no guarantee of the passenger safety. How are we going to stop the lift when the lift breaks, when the roof breaks? Yeah, so this is very important. So the first electric lift was invented or introduced by Siemens in Germany, where they used the electrical motor to drive the lift. Okay, as you can see, all this happened long time ago, more than 100 years ago. So what can you see here? Actually, this is correlated to the industrial revolution, to when electrical machine has been invented. Before that was steam, okay, or pure mechanical system. So now, 1996, Kony launched the modern machine roomless lift monospace. So this product actually bring a lot of advantage to the building owner, architect, as well as engineer, and also developer. Maybe what can you think of the benefit of the motorless lift? Maybe we have a quick short discussion.
Save the motorroom space
Yes.
near the construct.
Yeah, save the motorroom space. Yes, so this is very important. So another features is, in order to accommodate the machine into the lift shaft, Kony invented the slim type machine. And this slim type machine has no gearbox. So what does it mean? When it doesn't have gearbox,
Reduce the
maintenance becoming very more easier. This is for sure, because you don't have to change the lubricant, the gear oil, and then you don't have the mechanical losses, because when you have the gear, that will be the coupling loss. Okay, then for this kind of gearless machine, the shift of the motor directly attached or coupled to the motor. So that means the speed is actually synchronized. And then how we regulate the speed of this kind of gearless machine? We use an inverter to regulate the frequency and also the voltage. Okay. So maybe IR Chan maybe can also help us to understand a little bit. Okay, IR Chan, so for the VVVF, what is the advantage in comparison with the conventional drive star, delta star?
Even VVAF, they won't have the surge or starting M won't be high, because it will be regularly ramp up and ramp down control using frequency inverter.
Okay.
That's the beauty of it. Compared to the traction motor or the star, they will be 3 times the M higher than that. And then you have to 3 times, yeah, 3 times. Depend.
Yeah, good. I think good sharing from IR Chan. So another good thing about VVVF is, for the conventional lift with the variable voltage lift, in the past they apply the reverse voltage. When the motor is rotating, in the past they apply the reverse voltage to the motor, and then after that the brake drum will fully engage, and then to lock the so-called the rotor lock the drum. So that actually generated a lot of heat, and also it will also causing the brake shoe wear and tear. So for VVVF, they can actually regulate the frequency so that the speed of the motor will reduce step by step. We call it creeping speed. Creeping speed, so that you don't feel the jerk. And then before the brake the brake shoe apply, they already supply the motor with the zero frequency. So technically, rotor already stop moving, then only the brake shoe apply. So that is another advantage of the DVBF. This is last time we have a lot of the hands-on work lah to check that kind of parameter. So any question, Lance, you have?
So far so good, thank you.
So far so good. So Chan, you see the motorless lift. So is it very common in the market now?
Yeah. Now it's pretty common in using motorless leaf because technology allowed this kind of motorless and save a lot of construction costs in terms of this, and it become very matured already.
Very mature
already. And then control can be at the last highest floor usually mounted the control.
Okay. With you can see a good Motorola lift in where in the Changi Airport they have the ThyssenKrupp Motorola lift. So in KLIA, they have a lot of lift inside the departure hall. But those lifts are before invention of the Motorola lift. So they have to use the hydraulic lift with the plunger system. So that one is actually very, I would say, not preferred solution anymore, because you need a regular maintenance. You need to check the oil seal. You need to check the oil, change the oil. But in some places, hydraulic lift is still applicable.
Yes. Lift especially for very heavy duty, and then I think there no need more. Similarly, no need motor room. It can be place the hydraulic pump anywhere. Only need the hose. It can be. You have some restriction on the motor location. You can place it differently at a different location.
Yes.
My working experience formerly our Malaysia local company acquired a hotel in Okinawa, Japan. So I went there, we supervised a motor room, but it's a conventional elevator. Yeah. So we still need to hire the local technician to service the elevator system every now and then.
Okay. Yeah. Of course, maintenance is part of it lah. So we can move on. So history of the vertical transportation. So those are the literature review when they started having more research on the electric lift. So we are talking about when 19202. Why the development of the electric lift started, and since then they have a lot of the discovery, a lot of invention in 1900. Why? Because when there was a time where United States they started to build more and more tall building like Empire Tower and so on, so they need a lift. So though actually the invention or innovation in the electric lift is actually driven by construction industry. Okay, so therefore they have all those roofing system and so on. You see, electric power application to passenger and flight elevator. You see, transaction of American Institute of Electrical Engineers. So this is actually the predecessor of IEEE. Predecessor of IEEE. So from there they developed the standard for the motor. So vertical transportation in Malaysia. So I know that there are already a new OSA Act, right? New OSA Act, but what I know from my friend Zahir from Mitsubishi, they are still mainly referring to Factory and Machinery Act. That is still kind of the Bible for them. Because in the past they have been using that act for so long. Although I remember last time they have the safety code EN81. I asked them what is the code now. I think they also have different code.
Not many code applicable, but I can't remember the numbers.
Last time then they want to implement the lift safety code for the MS. They actually adopt from EN81. So, and in fact, that time I was one of the reviewer of the code. So, but having said that, they are still referring to Factory and Machinery Act because all the JKKP officer, they are very familiar with the act. Okay, in fact, for the first schedule submission, is actually still derived from the akta machine angkat something like that. PMA permit machine angkat. So, installer maintenance inspection of lift, escalator and dumbwaiter. So, what is the meaning of dumbwaiter?
For mainly without people
I
inside.
mean, without people. Dumbwaiter can be very big also. For library, it can be quite big. Mainly in the restaurant, hotel,
Food.
for food.
For rubbish.
For rubbish. For example, the kitchen, they already cook the food and then they want to serve in the restaurant in the different floor. I mean, we cannot use the manpower to carry, so they use the dumbwaiter. So that's why dumb means quiet waiter, dumb waiter. But dumb waiter is relatively simple. The electrical system is only the relay on off only up and down only, can be quite straightforward.
I visited a carrier in New York, US. There's a carrier got hanger system. Hanger system is also considered a vertical transportation.
Hanger.
They transfer the like whichever aircraft or what it can
Yes. It is also the
vertical
hoist,
transportation.
and then some of the scissors lift in some of the car repair. So it's also vertical, but that one is actually not really common but that one is very for the niche area. Okay. Then the lift competent person. This one. Okay. In Malaysia, lift is actually the usage of the lift is actually regulated by the Act, Factory and Machinery Act. Whenever you go into the lift, sometimes you see the notice, the permit to use the lift. So the lift must be inspected by JKKP. JKKP means Department of Occupational Safety and Health. Okay, so they will be the officer who are mainly engineer to inspect the lift, and the lift only can be installed with the submission to JKKP. So who will need to make the submission? Lift competent person. So if anything goes wrong with the lift, government will find this one to give the report. Lift competent person. The purpose of this guideline, so it's actually too long, but in the nutshell, this is the guide who can say the lift is safe for the use. Because the reason why we need to have the lift competent person to ensure the inspection and to ensure the safety is because it affects the public safety. I ask maybe for home lift, what is your understanding? Do we need to have this inspection or not?
At this moment, Malaysia don't insist that you have, but I think it would be a good practice to have it checked from time to time basis.
Still mainly under manufacturer responsibility.
Yes.
Under manufacturer responsibility. So once the lift is released for the use, so it is subjected to Schedule 3, second schedule inspection. I think the interval is between 18 months. 18 months.
Still the same.
Still the same, Yeah. So this is what I have extract from the JKKP website. Terima permohonan pemasangan lift, escalator melalui system. So I think now they already have the online system to submit the short drawing, and then the competent person need to attach the form, and then they need to provide the particular of the lift. They need to provide the manufacturer certificate as well as the certificate of the group. Okay. Yeah. So this is the flow chart. So after installation, after having satisfying the inspection criteria, the JKKP officer, on behalf of the Chief Inspector, Ketua Pemeriksaan Jentera, can issue sijil perakuan kelayakan certificate of fitness. So this is under mechanical, right, Ayatan?
Yes.
You follow up this one for mechanical?
You have to right?
You have to
Right.
Okay. So
I think previous year probably different trade of people still can register. Right now, most of it is mechanical discipline.
Mechanical,
Yes.
mechanical. So actually for lead competent person, they actually have 3 grades. Grade 1, grade 2, and also grade 3. What are the differences between grade 1, grade 2, and grade 3? Responsibility. Grade 1, competent person is representative of the lift owner. That means if let's say Mitsubishi, Kony, or Otis, they represent the lift company to prepare and sign and submit the first schedule to the chief inspector JKKP. So there are some calculation, shop drawing, and so on. And all those shop drawing, I think also will be submitted to MME. It's part
Yes,
of
and we need to sign G form,
G
G10, G11, sorry.
G11 form.
Yeah.
So in the past, like I say, the grade 1 competent person could be from electronic, could be from electrical, mechanical. But now what I heard is mainly mechanical.
Yes.
Mechanical. So there are many things that the grade 1 competent person need to do. Usually for the first installation, grade 1 competent person need to attend the inspection. But he can also delegate the responsibility of the inspection of the newly installed lift to the competent person grade 2. So notify the chief inspector of any accident or incident involving the lift under his care. So if let's say there is any accident happen, so he will be the one who need to submit the report. Especially those cases involve injury or the casualty, and he will need to provide the technical accident report and remedial action to the chief inspector, and he supervise lift completion grade 2 and grade 3, and he submit the declaration and also the so-called the indicating the function or the responsibility of the lift company, and he's usually reporting to the CEO, MD, or general manager of the lift firm, because he is actually representing the lift company. So grade 2 is actually 1 grade lower than grade 1 competent person. They usually do the inspection for the new installation, and grade 3 is mainly for maintenance. Because you don't really need to have a grade 1 competent person to do the inspection all the while. But of course, grade 1 competent person can also inspect the lift under maintenance schedule, no problem. So in a nutshell, lift competent person grade 1 must have design knowledge. Grade 2 competent person must be able to understand the design. Grade 3 competent person must know how to maintain. Okay.
I got friend working for Toshiba elevator lah. Last time he told me their company, they need to do tests to measure the elevator speed, all types of tests. But the Penang government or the Malaysian government allow them to build the current height is the maximum height they can build the building for testing the elevator.
So, test tower.
Test tower
They call it test tower.
So but I remember in Japan sometimes they want to measure because they want to do research on the rocket. They use roller coaster to measure to do tests also sometimes.
For this one no lah. For lift no. For lift is
only the vertical test tower.
vertical test, because this is the application is only in the vertical orientation ma. Okay. So we can have a recap, group discussion and quiz, and we can discuss the importance of the lift inspection. Okay, why we need to inspect the lift? I mean, to ensure functionality, it's still reliable, it is still fulfilling the specification, for the intended use. For example, it can carry the load of 1000 kg, it is still meeting the standard, meeting the specification. Yeah, so and then the speed, for example 1 meter per second, is still meeting the specification. So we need to ensure that. And then safety, all the safety components are functioning well, so it can actually and it can actually take effect when anything goes wrong lah. Okay, I think we can have a short break.